Did I not pass these out? Did I not? I could have sworn I passed them out yesterday. Then I will get those out right now. I thought I did. Okay. All right. So let's see. I believe it's only 2 pages anyway. Yeah. Okay. So here we go. All right, so we're going to be talking about linear regression today. So we're going to kind of be extending our talk of correlation. Yes.
I know it's extremely cool.
I am already staying after, but remember, tutorials in the afternoon only go to about 4:20. But I will be here. All right. Pass the papers. If the papers will unstick. There we go. 1, 2, 3. All right. Okay, so a couple things just before we go ahead and get started. You remember in a couple days, Friday's going to be the end of the 6 weeks. So please, if you are wanting to retake either the quiz from last week or the test from Monday, okay, the quiz from last week has a deadline tomorrow morning. Okay, if you want to go ahead and come on in by 8:05, the test you can come retake by 8:05 Friday morning. Okay, so please, one of the two. If you're having any issues, I think that's besides the focus activities, which I hope everybody has turned in, I think that might actually be the last grade for the 6 weeks, because the homework we're going to get on this particular section will carry over into the next, and then we'll start over again with new focus activities, quizzes, and all that good stuff. Okay, let's get going. All right, so linear regression. Okay, it's a method of fitting a line to a set of data and then finding the equation of the line. And we refer to it as the line of best fit. But it also has a lot of other names that goes along with it. You could call this the regression line. You could go ahead and call it the trend line. But typically, we go ahead and refer to it as the line of best fit, because when you're dealing with a scatter plot, we go ahead and try to fit all the points as best we can. Okay, only if it's a perfect association or a specific type of model are you going to have all the points following a specific pattern. Okay, so let's see here. Step 1, make your scatter plot of the data given. And then we want to talk about, would you say it's strong or weak, positive or negative? We could even go ahead and calculate the Pearson correlation coefficient R if we wanted to. And a lot of these we will. Find the mean of the x-coordinates and the mean of the y-coordinates. Okay, that is this one right here. This is what we call the grand mean. Okay, so depending on how strong your correlation is, how tightly packed the points are, okay, is going to can't talk today, is going to represent how valid or legitimate your regression equation, your line of best fit, is going to be. But if you go ahead and make sure to write the equation of your line, y equals mx plus b, using this grand mean, it just makes it that much more valid. Okay, so you always want to make sure to use that point when you're writing your equation. And it's really easy to do. We simply take the mean of both sets, x and the y. Now 3, by eye, draw a line which best fits the data with about equal numbers of points on either side and passes through the grand mean. Pick 2 points that are close to the line that you drew and find the equation of the line passing between them. This is the equation of the line of best fit. So we're going to go ahead and practice this. We're going to do one first by hand, and then I'm going to go ahead and show you how to do this on the calculator. And I think I kind of foreshadowed it a little bit yesterday, right? Didn't I show you how to draw the line? Okay, good. That's exactly what we're going to be doing in just a little bit. So this one is cut into 2 slides. The heights in centimeters and weights in kilograms of a hockey team are recorded as follows. Okay, so we have 21 players that we have data on, the heights in centimeters and the weights in kilograms. Okay, so A, make a scatter plot of the data from above. Okay, so I've already scaled mine right here. You'll notice I'm starting my, that kind of got cut off right there. So I'll simply redo that. Let's see here. I think the lowest weight we have, looks to me like 60 might be the lowest. Do you see any less than that? No? Okay, so I'm going to go ahead and start this at 60. And then we'll say 65, 70, 75, 80. What's the highest we got to go? 84. Okay, so I would say we're good with 85. Okay. And then I went ahead and started my horizontal axis right here at 160 because that'll definitely encompass all the rest of them. That's the lowest one. I already see it at M and N. Okay, so all we have to do first is simply create the scatter plot. So we're just plotting our points. Okay. Would anybody want to come on up and help me with a few of these? Good opportunity to come on up, and it's really easy. Okay. And you could say you get the point as you bring it the point. I'll even go ahead and get the ball started. So A is 183 and then 85. So let me go ahead and do this in a different color just so we can easily see these. So 185, it should be 83. Okay, so right here, and I'm going to go right up to 85. So right there would be 183 and 85. Got that taken care of. All right, so who wants to come on up and have the same amount of fun I am? Hey, Libby, all right. So she's going to do, let's go ahead and do like 2 or 3, and then we'll get some other folks up here. Everybody can share in the joy. So I'm looking for 170, 74. Oh, it's putting it in yellow. That's interesting. Oh, did you go ahead and choose yellow?
No.
Oh, that's weird. Oh, you did choose yellow. Okay. Interesting. All right. Please. Okay, so now we're to 174, 76. Okay. Okay. So that's good. All righty. Good. Who else wants to come on up? Sure, let's do that. I like that idea. Michelle. And then we'll just go ahead and run through that way. That'll make it go smoother. So Michelle will choose, and then her volunteer will choose, and then so on. Libby, is yellow your favorite color? No? Oh, there you go. Okay. So now we're to 168, 69. Okay, perfect. Okay, who's up next, Michelle? Okay, Alejandra. Yes.
I didn't mean to do that.
Oh. That's okay. So 167 and then 68. Okay. I agree with that.
Good job.
All right. Let me mark these off as we go. We just did 167, 68. We got all those taken care of. So now we're on 177, 74. Okay. Okay, John, who's next? Samir. Okay, now we have 162 and 62. There we go. Perfect. Okay, now we got green. All right. We're going to have a whole rainbow of colors here. All right, next up. 167, 67. Spencer's got that one. Okay, good. Perfect, perfect. Next up, 169, 74. Eli. Okay.
No, that's not it. Yeah. Is that it?
Yeah.
Okay, great.
Okay. Perfect. Eli, who's next?
All right.
Okay, Raya. 163.67. 163.67. Okay.
Jocelyn.
All right. We're getting close. 161.69. Okay. Okay, Zoe's up next. So let's see here. Okay, so she has L 172.74. Okay, that'll work.
Emily.
Okay, Emily is up next. So, okay, 160.64. Perfect. Okay. Okay, 160.62. Okay, perfect. Okay, Sierra. It's like 167.72. Oh, and there we go. Okay, Gabby's got 171.69. Guess it. This is the most colorful scatter plot I think I've ever seen.
Okay. What am I doing?
You are on 171.69.
Oh, that missed. I'm sorry.
Yeah.
I'm sorry.
I think the calibration is slightly off, but that's okay. I can. I just need to do it when we're not in the middle of class. Yeah. Yes, I mean, yeah, we're okay. We're close enough. All right, now who's next?
Okay.
Caitlin. There's only 5 left. She has 170.76. No. Well, no, we're making a point, so I don't know if it. You just want to draw with it. There you go. Okay. There. 170.76. Okay. All right. And she marked it out for me. Thank you very much. Okay, who's next, Caitlin? Peyton. 174.71. Okay. 174.71. Next up. Okay, Karime. 162.71.
Which one is it?
162.71.
Is it this one?
Yes, there we go. Perfect. Okay. Hillary is up next. 187.84. Okay, there we go. All right. And who will have our last point, Hillary? Kiana. 175.77. Oh no. We shifted the points. Oh, that's okay. That's okay. We're on the last one. She accidentally shifted the graph. That's okay. That's okay. I will say, all the years I've never had that happen. Wow. Okay, so I'll tell you what. All right. So I'll tell you what, we could do one of two things. We could erase them, and I could quickly go back and just plot the points, or we could just kind of estimate off what we have. Estimate off what we have. Okay, does anybody remember, like this point right here? What was this? Is there a 161? I know there's a 160.62.
You can undo it.
Oh, that's right. That's right. There we go. Now I think that did it. Was there one more? Is that it? Okay. So are we down to our last point, or did we still needed the T, or we're good? I think we got the T there. That was 187.84. Okay, so 187.84. Okay, we're there. All right, and Kiana, I'll help you out on this one. 175.77. So 175, so it did erase her point. So right here. Okay. There we go. So we have our rainbow scatter plot here. All right, so that part's easy. That's just plotting points, okay? So let's go ahead and draw my trend line. So let me get a little line right here. So let's see. I want to go ahead and try to put it through as many points as possible, okay? With about as many points above as below, okay? Now, I'm doing this before we even go ahead and calculate the grand mean, so let's see how well I placed that particular line. I need someone to help me out with this now. I need the average of the heights, and I need the average of the weights. So, for example, 183 plus 170, all the way through 175, and then divided by 21. Okay, let's see if you already got it? Okay.
Does it matter where you start or finish the line?
Well, the y-intercept will play an important part in this, but it's really the data itself. So you don't always necessarily want to start at 0. You want to try to fit the points, not always come off, say, the origin or something like that. Okay. So, Kiana, do you already have the average? Oh, okay. Yes. Uh-huh.
We see like real life scenarios of scatter points where there's more data than this to see. Because right now, like we just plotted like a few points.
Uh-huh.
Where it's easy to tell if it's like moderate or strong. So we see like real ones where there's like hundreds of data, so we can really see if this shit can hurt.
Well, I mean, there also gets a point where you have more data than is needed. I guess it depends on what you're comparing. But, yeah, you always want a good representation for whatever it is that you're trying to analyze. You know, here we have, I'm guessing, all of the players on this hockey team. I don't know, is anybody in here a hockey fan? How many players are normally on a hockey team?
Go Cotton King.
Is it 16? Is it 9? 10? Maybe they have alternates? I have no idea. Okay. But there you go. Well, I mean, how many years ago was it that we had the Cotton King?
I think they left in like 2008.
Yeah, it's been a while. Okay. But anyways. There are 20? Did you Google it real quick? Oh, okay. Well, there you go. So she says 20. So she seems pretty confident about that. So we're going to go exactly off what Gabby says. Hey.
For the weight, on average, on the mean, I got 71.6.
71.6. Perfect. Okay. So Libby helped me out with that. She says 71.6. Has anyone helped me out with the height? Okay, 169.5. That's exactly what I got. Okay, so let's see how well I placed, and let's go ahead and use a color that we don't have so we can tell the deal here. Well, we got a blue. Maybe this baby, well, we got that baby blue. Pink? Okay, let's do pink. There we go. So I'm going to go ahead and put this grand mean in pink. So 169.5, Okay, so that would be right here close to 170, and then we have 71.6. Okay, so right about there. So I was pretty close. I'd say I did a pretty good estimate, if you'll do it with my finger, but there you go, of where that grand mean is going to be. Yes?
I looked it up just out of curiosity. There's 6 players six players on the field.
Well, on the field, though, but how many on the team?
20.
I think it just depends.
I have no idea.
You can play with 6 players. It's probably not a good idea, but you can have 6 players on a team.
Yeah.
Don't they get hurt a lot?
Well, yeah, there's a lot of fights, you know.
16 and 20.
16 and 20? There you go. We'll estimate. Mathematics at work. There you go. All right. Now, here we go. So this point that's pink, that's my grand mean. So it actually turned out to be really close to the line that I drew. Now, here's what we're going to go ahead and do. Okay. We're going to go ahead, pick 2 points close to the line of best fit that you drew, and find the equation of the line passing through those points. So this is going all the way back just to good old Algebra 1. Now, we're going to use the grand mean, the 169.5 comma 71.6, in order to write the equation. But let's go ahead and choose 2 points, because I do need to find what? I need to find the slope. Okay, once I have the slope, I've got a point, then we can go ahead and use point-slope form. Do you guys remember that? No, that's slope-intercept form.
What's point slope?
Y minus y1 equals m times x minus x1.
What's that?
That's point-slope. Yeah. Okay, so a good thing we're talking about this. So I need 2 points. So you guys help me out. What 2 points do you believe are closest to this line that I drew? That one and that one. Okay, that narrows it down. There we go.
Wait, could be like 160, 64.
Okay, so 160, 64? Okay, I'd say that's a good point. So 160, 64. That one is almost right on top of the line. What would be another point that's on it or as close as possible?
175,
175, 77?
77.
Okay, so let's see, 175, 77. I'd say that's perfect. 175, 77. So these are the points that Eli chose. Would you agree with them?
Sure.
Okay. Now, here's the thing. If you were doing this individually, what are the odds that you guys would all choose the same 2 points? Okay. Probably not very high. But you're choosing points that are as close to this line as possible. You know, so while your slopes are going to vary, should they all be relatively the same? Yeah, we shouldn't see any major differences, okay, or hope there won't be any major differences. So let's go ahead and find that slope. Okay, so the slope is the change in y over the change in x. Okay, so I'm going to go ahead and I'll just go from 77 minus 64 over 175, okay, minus 160, okay. So first off, I need a 77 minus 64. 13 divided by 15. 13 fifteenths. Okay. Now, here's the thing. I'm going to go ahead and approximate this. I do enjoy working with fractions because, you know, they're fractions. But since my other values are already decimal, I'm just going to go ahead and make all the values consistent. Okay. So let's figure out what 13 fifteenths is. Oh, and it's going pink, so I'm going to go use my mouse here. Calculate. Okay, so I need 13 divided by 15. Okay, so I'd say maybe a 0.87. Would you guys agree? Okay, so 0.87. Okay. Okay, so that's about 0.87. Now we want to use that slope and this grand mean, 169.5. And was it 71.6? Okay. In order to write it. Now, just so you remember this or kind of get a refresher, let me list all the different forms of the lines that we have. And you may or may not have been taught all of these back in Algebra 1 or Algebra 2, but y equals mx plus b, we call that what? That's slope-intercept. Okay, that's slope-intercept. We need the slope and the intercept. That's the form that we're ultimately going to write our equation in. Okay, my trend line. Now this one, y minus y1 is equal to m times x minus x1. Now that's what? That's point slope. Okay, with your x1, y1 being the x and y values of your point, m is our slope. This x and that y, those are just what we call generic variables. They have to be there as part of the function. Okay. Does anybody remember standard form? I mean, it's nothing to do with this. I figured I might just throw it out there.
AX plus BY equals C.
AX plus BY is equal to C. Yes. Okay. Now, hopefully when you were taught this, right, Hillary? Okay. You were also taught the 3 restrictions to put it in the correct standard form. Does that sound familiar?
Yes.
Okay. Can anybody tell me one of the restrictions on standard form?
We don't have a value for C.
No. I'm just saying in general. This is just a little review. Kind of FYI.
It doesn't say the slope. Right?
Well, actually, if you take the opposite of A divided by B, you can get the slope. Okay.
Trying so hard.
Okay. Yes.
Wait, are you saying stuff like stuff that you can't do within?
Yeah, because a lot of the state tests and things like that really don't adhere to these conditions, but mathematicians, when you're talking about standard form, you want them in a specific form. So there's 3 rules that we have to follow. All right, so can anybody tell me one of those rules?
You can't add A and B.
Well, you wouldn't be adding A and B because they're not like terms. They're coefficients of x and y, so that's technically correct. I'll just go ahead and list them. Let's see if they sound familiar. 1, A has to be positive. Okay. Coefficient of x can't be negative. Okay. 2, this is typically everyone's favorite. No fractions, no decimals. They all have to be whole or integer values. And 3, A, B, and C can have no common factors besides 1. Does that sound familiar? Did you guys ever go over those? Did you know the okay, all right. And there was one other one that when I taught Algebra 2, I would go ahead and show my kids. And this relates to the eccentricity of graphs, which is why it equals 1. But you would say x over the x-intercept plus y over the y-intercept is equal to 1. That's also the equation of a line. Does that look familiar? That's what we call double intercept form. So if you know the intercepts, both the x and the y, you can immediately just plug it in, and you can get whatever other form you want. Okay, so nobody here was ever shown double intercept form? You were? Really? What teacher showed you that? Okay, cool. All right. So there you go. There are other versions of lines, and we kind of got a little off topic, but that's okay. I figured it was a good opportunity to go ahead and bring that stuff up. So now back to this problem. So we're going to use point slope, and Eli, what is that?
Y minus Y1 equals M times X minus X.
Yes. Okay. So y minus y1 is equal to m times x minus x1. So here's my x1, my y1 values. We've got my slope. Well, all I need to do is plug in and then just manipulate the equation until I get the form that I'm looking for. Okay, so y minus y1. So that would be y minus 71.6 equals m 0.87 times x minus x1, x minus 169.5. Okay. Now, there's only a couple things I need to do in order to put it in slope-intercept form. First off, is everybody okay with how I did this? Just bringing back memories of Algebra 1 and 2?
Yes.
Okay. Okay. We're definitely not lying. Line. Yeah, okay. Next up. So I'm going to have to distribute this. Okay. So I'm going to distribute this. So we have y equals, because I'm going to go ahead and take care of a couple things at the same time. Well, 0.87 times x will give me 0.87x. Now I got to figure out what that is, because off the top of my head I don't know. So 100, and it's still doing the pink, so I will come over here. And you guys probably are going to be able to get that faster than I can. There we go. So 169.5 times, it was 0.87, right?
Oh, I put 0.87.
Okay. Now this is 147.465, but I also want to go ahead and do what? Subtract, add the 71.6 over. Okay, add the 71.6 over. So let's see here. Okay, so plus 71.6.
Wait, but it said 147.5.
Oh, I'm sorry, that's negative. You're right, I'm sorry. So let me do this. Just seeing if you were paying attention, and obviously you guys were, so there you go. So I'm going to put in that negative right there. Now I'm going to go ahead and add, there we go. I'll just do this. Yeah, it's a Wednesday. 71.6, there we go. So negative 75.87 is what I'm getting. Would you guys agree? Negative 75.87. Minus 75.87. Since we have this one rounded to the hundreds, I'll go ahead and round that one to the hundreds as well. So this is what we came up with that's going to help me predict, okay, other weights or heights as I'm given them. Okay. Now, doing it by hand is great. Hey, Libby.
Really fast, sorry. Where'd you get the M from again?
Oh, the M? These were 2 points that we chose from the scatter plot that we believed were closest to that line. So we chose 160, 64, 175, 77, and then we found the slope between them. Okay. And then we used the grand mean itself with point slope to go ahead and get the equation. Okay. So now we went through all this by hand. Well, now let's go ahead and see what the technology is going to say. Let's see how close we actually got. All right. So hopefully we're going to be very close to this. If we're far off, that means we've probably made some kind of mistake. All right. So I've got this paper here because that's a lot of values to put in. All right. So let me document B out of this. So I'm going to go to my home screen. So let's say that I do want to go ahead and plug all this data in. Where do I start? Okay, so list and spreadsheets. So new document, list and spreadsheets. Okay. And of course we can type in, height and weight. I'm just going to go ahead and take the easy road, say X and Y. All right. And now this is just going to take a moment to type all these in. Okay, 174, 168, 167. And you guys can follow along and make sure I don't make a mistake. Like that would ever happen, right? A little more talking on that thought, but that's okay. 163, 161, 172. I believe the next one's 160, 160, 167, 171, 170, 174, 162, 187, and 175. So hopefully that should be 21. Yes. Okay, I got them all in. All right, and Control 7 will get me right back up to the top very quickly, where I will put in 85, 74, 76, 69, 68, 74, 62, 67, 74, 67, 69, 74, 64, 62, 72, 69, 76, 71, 71, we're almost there, 84, and 77 matches up with 21 again. Yay. Okay. So I've got all the data in. All right. Now let's go ahead and run through the keystrokes just to go ahead and find the correlation coefficient, and then I'll show you what I did yesterday, again, how to get that equation line. So what do I do? How do I bring up the correlation coefficient? Okay, go to menu, statistics, stat calculations. Remember, this is two variable because we're comparing two different quantities. All right, let's go ahead. The X list is the height, I believe, but we said it was the X. All right, tab, put in the Y value there. There is no frequency list, so I'm going to take care of that. And it looks like it'll appear in column D. So let's see here. Here's all my information. Oops, it's the bottom. There we go. So according to this, my Pearson correlation coefficient is roughly a 0.88. How would you classify that? Weak, moderate, or strong? Strong. Remember the interval we were looking at the other day had it between 0.75 and 1 as being strong. Okay, good. Now, we already know that. That's what we've been practicing, for a couple of days now. But here's what I'm going to do. If you want to not only see the scatter plot, but also come up with the equation that we just did, okay, here's what we're going to do. Let me go back over here. So you're going to go back home. Now, do you guys remember what I told you yesterday? There you go. Again, you can go to new document, or choose it again from there. But at this point, I like to go ahead and use the icon down here, data and statistics. So I'm going to choose enter. This is the one time where it's just going to take those points and it's going to throw them on your screen. So we have to tell it the x and the y axes. So I like to hit tab and always choose the horizontal first. So there's my x. Okay, gives you that little dot plot. Then I'm going to say tab, and there's my y. Okay, so the scatter plot that we created, okay, should look just the same. A little off because of the calibration, okay, but that's okay. Now, all we got to do is figure out what that equation is. How do I get there? Menu, analyze, regression. Remember, we call it a trend line, line of best fit, regression. And we want mx plus b. Okay. And there we go. So let's see, how well did we do by hand? We are showing a slope of about a 0.74, and we got a 0.87. So we're not too far off. Okay. We are a little further off on the y-intercept. This says a negative 75. And this one says what? Negative 54. Okay, so I'm guessing there are probably some points that were better to go ahead and have chosen in order to write the equation. But I would still say we did a decent enough job, okay, especially doing it by hand. Okay, questions? No? Okay. All right, well, I'll tell you what. Instead of moving on, because it only looks like we have the one page left, why don't we go ahead, we'll just stop there for today. Yay! And we'll